Sometimes they want us to graph numbers on a number line. So we're going to talk a little bit about the number line. So our first example here says locate and label the following on a number line. So I draw a straight line, or try to draw a straight line with arrows on the ends. I'm going to go ahead and put 0 in the middle, and we'll just count out 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7 in the other direction. I'm going to go ahead and label my number line. So 1, 2, 3, 4, 5, 6, 7, -1, -2, -3, -4, -5, -6, and -7. Okay, now I just kind of eyeball it. You can, get more accurate using a ruler. Okay, so here we go. We're gonna put these numbers on a number line. So what we do is our first number is -1. We just draw a dot at -1. It's already labeled, so I would probably just leave it that way. 1/3. Okay, so our next number is 1/3. Maybe if I change it to a different color, it'll help you. So I'm going to have to just kind of eyeball it. I'm going to say it's about there, probably a little too far to the right, and I'm going to label that 1/3. My next one, 6/5. Okay, I have to kind of think about 6/5. That's the same thing as 1 1/5, if you want to think mixed numbers. We've talked a little bit about mixed numbers, but we really haven't done a lot with them. But you just divide 5 into 6, it goes once, with a remainder of 1/5. We could draw that out or something. So I know it's more than 1. So I'm going to go to the right of 1, and I need to go about 1/5. Yeah, so not too far. 1/5. Oh, nope, 6/5, sorry. 6/5. Okay, now we've got a negative number. So -7/4. Okay, so that's like -1 3/4. So I'm going to go to -1, but then I need to go more to the left. So it's going to be like, let's see, maybe around there. Probably a little more to the left the way I have it drawn, but -7/4. Okay. Now let's see, I'm running out of colors. 9/2. Well, 9/2 is 4.5. So if you divide the 2 into 9, it goes 4 times with 1 left over. So 4.5 is going to be about there, a little to the right maybe. 9/2. I'll change that. Try it a little better. 9/2. Okay, 5. Not a problem. 5 is just going to be at 5. So right there, and it's already labeled. And then -8/3. Okay, so I'll go over this one in a little more detail if you're having trouble with it. But 3 goes into 8. How many times? 2. 2 times 3 is 6. Remainder 2. So it's -2 and 2/3. That's how we do that. So it's this number over that number for the fractional part. I'm sorry, they just both happen to be 2, don't they? Okay, so don't listen to that. This is the 2, the whole 2, and then it's this number over that. It's the remainder over the divisor. That's the fractional part. Sorry about that. Okay, -2 and 2/3. So -2, so I'm counting to the left of 0, and it's going to be closer to -3 than -2, right? So it's going to be like maybe in there. And that's going to be my -8/3. Okay, so we just kind of eyeball it, and that's how we graph these on a number line. So we had some fractions and some whole numbers in there, integers. Okay, now we have some decimals, and they go into the book. In the book, they go a little more detail with this. So for A, what they do is, okay, so here's a number line. And let's say here's 0, and then let's count, and what they do is they count it by tenths. So they're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and making that the 1. And so 0.6 would be 1, 2, 3, 4, 5, 6, be like right there. So you can put more labeling in to help. I'm sorry, you could if I didn't do it wrong. Okay, try again. So this would be like 0.5, this would be 0.6, where I have the little blue dot. Now, at first when I saw this problem, I'm like, well, usually for our algebra purposes, we don't get that detailed, but we could be measuring something like rainfall where we were doing it, in tenths, and we wanted to be that accurate. If we're not being that accurate and we have 0.6, we're just going to estimate like we did with the fractions in the previous problem, just kind of estimate where it is. But you could make it more detailed. In part B, they do something similar. They draw a number line. And then they say, well, let's make this hundredths then. So let's see if I can get a little more room. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and making this 0.1. So making this like 0.01. And I'm not going to do them all, they won't fit, but you can do this. Sometimes they'll do this where they just put in some of the numbers. So I'm doing the odd ones here. Okay, kind of ran out of room there. And then we can kind of guess where, oh, well, I'd have to go farther. Okay, sorry about that. I need to go far past 0.1, so I need to redo my number line here. Rather than redo this whole video, I'm just going to redo this problem. So let's try again. Sometimes that happens. That's why we do math with a pencil. Okay. So let's go ahead and make this, oh, it's negative, isn't it? So I need room to need even more room. Okay, let's make our 0 over here. And then let's make this, negative 1, negative 2, negative 3. And so where is that going to be? And you know what? I've done it wrong again. Might have to redo this video. This is not the one I want to be doing. Okay, let's try again. This is going to work. Here's 0. And we need to go in a negative direction, but we're going to go negative 1, negative 2, negative 3, but not negative 1, negative 0.1. So negative 0.1, negative 0.2, and negative 0.3. There, that's what we want to do. Okay, so it's going to be negative. It's going to be negative 0.25. So it's going to be between negative 0.2 and negative 0.3. It's going to be like halfway in between. Now you could make, 10 little marks in there and get it more accurate, but I've already spent a lot of time on this problem redoing it. So, okay, so negative 0.25 according to the scale. So it's the scale that we're changing here on these. In this example, we're changing it so that each little mark isn't necessarily representing an integer, but in this case, it's representing 0.1 increments, okay? And then because it was negative, we had to go to the left of 0. Anyway, that's how you graph it, and we'll be done.